Hello, welcome to the Psycop webinar. My name is Jacek Grymuza and I'm a network security evangelist at Psycop. During this session, we will discuss how to effectively use the Psycop network security monitoring system in the process of network and security monitoring. I will start my presentation by explaining to you what NetFlow is and how to use it for network monitoring and security. Next, I will talk about the product's distinctive features, and in the next part, I will present selected use cases, and finally, I will conduct a short demo. Let me start by asking you a question. Have you ever wondered what the effects of network malfunction are? If not, I will explain it to you now. Network malfunctions can lead to downtime, during which essential services or communication channels become inaccessible. This can disrupt business operations, decrease productivity, and affect customer satisfaction. Moreover, they can damage an organization's reputation, leading to a loss of trust among customers, partners, and stakeholders. They can result in the loss of valuable information, customer records, or intellectual property. Poor communication can lead to frustration and ultimately the loss of key partnerships. They can lead to regulatory compliance violation as well. And downtime and disruptions caused by network malfunctions can result in financial losses for business due to loss revenue, missed opportunities, and potential penalties for failing to meet service level agreements. Network malfunctions can create security vulnerabilities that expose the organization to cyber threats such as malware infections, data breaches, or unauthorized access. Hackers may exploit network weaknesses to gain entry into the system or disrupt operations. Competitors may gain an edge by offering more reliable services or solutions. So let's consider an example of the effects of a failure on Facebook from 2021. The outage was caused by loss of IP routes to the Facebook DNS servers, which were all self-hosted at the time. And the outage cut off Facebook's internal communications, preventing employees accessing some corporate services. As a result of outage, other Google services slowed down, such as Google Public DNS, and Gmail, TikTok, and Snapchat. The site Down Detector, which monitors network outages, recorded over 10 million problem reports, the largest number for an incident to date. During the day of the outage, shares in the company dropped by nearly 5%, and Facebook CEO wealth fell by more than $6 billion. And of course, Facebook lost at least $60 million in advertising revenue. Few days ago, Facebook had another outage, and thousands of problem reports from users that were visible on the Down Detector. But I will talk about the effects of this failure another time, because it is too early to determine the full effects now, since not all users have regained access to the platform yet. So we can see that the network problems are very costly in every respect. So during today's presentation, I will try to tell you what you can do to quickly detect various types of network problems to limit their effects. Network visibility and network observability are two key aspects of managing and monitoring computer networks, but they differ in their scope and approach. Network visibility refers to the ability to observe and analyze network traffic in real time. providing a complete picture of what is happening on the network at any given time. Network visibility helps you quickly solve problems, optimize performance, and respond to network anomalies. Network observability, on the other hand, refers to the ability to understand and diagnose network behavior based on all available data, but not necessarily in real time. The benefits of observability include easy tracking of network activity, providing a more complete picture of the situation, make it easier to understand the cause of problems at the level of the entire infrastructure, not just individual components. A comprehensive approach to security monitoring is defined by the so-called SOC triad, which includes EDR, endpoint detection and response, NDR, network detection and response, and CM, security information and event management, enabling better visibility, more effective detection, and faster response to cyber threats. EDR provides detailed data on endpoint activity. In turn, NDR in the SOC triad enriches security analysis by focusing on network traffic, thereby providing a more comprehensive approach to identifying, analyzing, and responding to threats in the network environment. And the subject of further consideration during today's session will be to show the added value associated with network monitoring, and especially NetFlow monitoring for detecting network anomalies and security threats. As we can see, NetFlow has many advantages. For example, data size is smaller than pickup. Data analysis is fast because the information in the NetFlow does not contain all the details. And the deployment is fast because you only need to execute a few commands on the router. Flows are generated by network devices and contain a specific list of fields, information about IP addresses, ports, protocols, network interfaces, TCP flags, time, as well as information about bytes and packets. Flows contain information about who is communicating, what services it concerns, on what interfaces, when, what metrics accompany this communication, as well as other enriched data. NetFlow plays 4 important roles in network monitoring. The first one is network and application performance monitoring, which provides information needed to optimize network performance, for example, through better bandwidth management, delay reduction, or quality of service. Network monitoring and analysis are key aspects of maintaining the stability and operational efficiency of the organization, contributing reducing the number of failures in the IT infrastructure. In addition, it provides a more complete picture of the situation, which makes it easier to understand the cause of problems at the level of the entire infrastructure levels, not just individual components. So this is the observability. Access to detailed information about network traffic allows you to quickly locate and solve problems such as network congestion, data transmission errors, or system failures. Observability allows you to track how different network components cooperate and what actions they take in response to specific events. NetFlow is also used for billing purposes in telecom companies and for the effective use of network bandwidth and thus reducing organizational costs. Of course, knowing the characteristics of network traffic in the organization's infrastructure, you can make decisions regarding adjustments to current or future network needs. In addition to the obvious issues related to network monitoring, thanks to NetFlow, we can detect network security threats such as, for example, DDoS attacks, infiltration, and intrusion attacks. Network traffic monitoring can be used as preventive and control measure to meet regulatory requirements such as, for example, GAPAA, PCI DSS, NIS2. NetFlow can be used for forensic analysis because it allows you to analyze traffic between hosts, and NetFlow data may be used in criminal investigation. NetFlow data can be used in other systems, for example, anti-DDoS or SIEM, in order to correlate data or integrate with threat mitigation mechanisms. In my opinion, network team must have a system that looks at the entire organization independently of other systems in order to effectively manage the network infrastructure in the organization. Security teams should have such a system because many network anomalies can be security related. So it is a perfect complement to standard security monitoring. For the IT team, such a system for monitoring flaws is also needed when diagnosing various application and network problems. Therefore, one monitoring system can be used by users from many departments of the organization. SecOp is a network performance monitoring system with a security monitoring and consists of 3 modules. The basic module of the SecOp system is visibility, which allows for the analysis of network traffic in the context of the entire organization. Thanks to this, we know who is talking to whom, on which ports, on which interfaces, and how many bytes and packets were sent. The performance model is used to analyze application and the network performance, as well as increase visibility by providing application layer 7 information. In turn, the security model is used to detect network security threats and support other security operations processes such as incident handling, forensic investigation, or threat hunting. SecOp is a virtual machine to which traffic from network devices such as routers, switches, firewalls, or dedicated props is redirected. You don't need to install any agents, just enter a few commands on the network device to send flows to our system. So as you can see, deployment is very fast and simple. As I mentioned previously, deployment is simple and quick, and the entire implementation can be completed in as little as 1 hour. The system has a set of standard content, which includes dashboards, rules, queries, making using the system simple and efficient. It is also worth noting that content of the security module has been tagged with MITRE ATT&CK tactics and techniques, which makes it easy to understand the generated alerts. For organization with non-standard requirements and the system can be tailored to your needs, you can create on custom content. And what is data deduplication? If the traffic goes from many devices, the flows are connected into a single connection log. So the individual data from each device is stored in multi-value fields. Network query language allows you to create advanced mechanisms for detecting network anomalies and security threats. I will show examples later in the presentation. Anomaly detection is possible using static rules, dynamic baselines, or of course dashboards. Automation and integration are possible thanks to custom scripts or sending alerts to third-party system. Flows analysis in CM system is sometimes very expensive, so it is worth considering using the Cycop system for flow detection and analysis, and then sending only detected alerts to the CM. Licensing model is based on performance, not on data store. So we can extend the data store to keep the data for a longer period of time. Flow monitoring is vendor independent. The system supports all popular NetFlow formats. And the discovery mode allows you to add custom fields to the system. And then the big advantage of this solution is the ability to flexible analyze data from many perspectives. For example, after clicking clicking on one KPI, we can go to another context. For example, threat detection analysis, and then go to alerts table. This allows us to perform flexible analysis just by moving between different contexts. And the Rust client functionality allows you integrate with other systems. All we need to do is configure such a function in the system and add it to the selected rule. For example, in Cycop system detects suspicious activity and add as a result of action triggers a script to scan a suspicious host within the organization for the presence of specific vulnerabilities or to obtain additional information about such a host. And here we see you can see an example that we save the scan results on the webhook. And we can access this data directly from the graphical user interface of Cycop system, thanks to the right click correlations in the alert ID field. Of course, we can also imagine other scenarios, for example, transferring information to a system blocking network traffic or to a given host in order to perform mitigation. Therefore, thanks to such integration possibilities, the Cycop system can be considered as an NDR class. Multi-tenancy functionality will soon be available in the Cycop system and enabling effective management of multiple instances of the Cycop system from one place. So if you have many instances of Cycop, you can manage them using multi-tenancy. IT asset discovery displays some statistics for monitored assets. This functionality will be available soon too. The performance module allows you to enrich the added data, including application name, detected by deep packet inspection, JA3 hashes, or fields of some services such as HTTP or DNS. Here we see a typical network performance problem in which the key is to diagnose whether the problem is on the network application or endpoint side. So it's very often we very often observe such issues. And thanks to standard views and the drill down, you just need to make 2 clicks and you can immediately see where the problem is. What about network visibility? There are many ways to represent traffic and in Cycop. The ability to show the same data from different perspectives. For example, correlation charts can help detect non-obvious threats. often invisible from the point of view of other monitoring systems. So this is a very big added value. A typical observation is one-to-many, as you can see here. One-to-many analysis, which may indicate normal communication with the server, but may also indicate security threats such as the spread of malware. Network observability in SciCop is possible thanks to trends and deviations and deviations from the so-called dynamic baselines. So we have a lot of functionality which help to detect anomalies in SciCop. Exactly, you can use a reference point, you can use a reference line to detect some deviations in your network. Okay, the next case is related to a company from the telecommunication industry, which uses our system to observe the characteristics of backbone traffic by monitoring autonomous system numbers, which allows it to make a decision related to routing. So based on this information, they can change routing and they have save money. Yeah. So in this case, effective network traffic management resulted in financial savings. And network monitoring systems such as SciCop help you meet regulatory requirements such as DORA, for example, and to meet the requirements, both financial entities and service providers will have to take even more care of security, and as well as the DORA consultation documents collection, detection, and prevention system will be necessary in the context of security, network, and performance. So many needs are results of regulations, security regulations. We also have content related to regulations. For example, we are able to detect unencrypted communications, unencrypted communications in the context of PCI DSS assets. So we are ready for new regulation and current regulation. Based on MITRE attack knowledge base, we can see that many techniques can be detected based on NetFlow. And in a moment, I will show examples of such detections using the SciCop system. On this picture, we see a diagram of an example network infrastructure. In the initial access phase, the attacker tries to get into our networks, for example, through phishing, and SciCop has rules in its arsenal to detect this type of activity, mainly based on monitoring IOC. In the discovery phase, and the attacker tries to learn about our network environment, and here we also have rules to detect security and network anomalies. And in the lateral movement tactic, the attacker attempts to jump between hosts in the organization. In the collection phase, the attacker collects data of interest to him, and in the exfiltration phase, the adversary tries to steal data from the organization. Of course, there are more tactics for detecting adversaries, and according to MITRE, there are 14 such tactics. So we can see other examples of threat detection. For example, impact. There are rules for detecting DDoS attacks. In situ, there are attacks detected based on the reputation of hosts. The next very important issue related to network and security monitoring is zero trust. Zero trust is an IT security strategy that states that Organizations should not automatically trust any user, device, or application inside or outside its network. So zero trust includes, among others, identify verifications, access management based on security policies, privilege minimization. So NetFlow monitoring supports the zero trust concept by providing network traffic data that is necessary to implement zero trust principles. For example, network security anomaly detection. NetFlow data allows you to monitor user activity on the network, which enables precise management of access to resources at the level of individual users, devices, or applications. NetFlow data analytics can help you quickly respond to security incidents by providing information about attack type, source and target, enabling quick remediation. So, and NetFlow monitoring also allows you to verify the effectiveness and compliance of security policy principles within the zero trust approach. Thus, NetFlow monitoring is also an essential element of your zero trust security enhancement strategy, providing key network traffic data that is necessary to successfully implement the maintain zero trust policies. Of course, thanks to zero trust, even if the network is hacked, the attacker will encounter additional layers of security that will make it difficult for him to access valuable resources and of course limit the damage resulting from the attack. So this is the reason why zero trust is very, very important. The power of dashboards. You can use many drill down and filtering function in network data analysis in SecOps system. You can create custom rules or use built-in rules to detect suspicious activities, generate alerts and run some commands to third-party system. Powerful search. You can use NQL language to create advanced searches during network traffic analysis. In this part of the presentation, I will present specific examples related to the possibility of detecting threats thanks to NetFlow monitoring. For this purpose, I will use SecOps and all threat searches will use NQL network query language, which is the query language of the SecOps system. Let's consider activity related to pickup bot Trojan by analyzing network traffic. Communication with C2 takes place on high ports or ports identical to Quackbot proxy, for example, 114094, 2078, and other. User agent should also attract the attention of an analyst or threat hunter because it is non-standard. So these artifacts may be detected based on network traffic with enriched application data. Based on NetFlow monitoring, we can hunt for threats in the context of DNS protocol. DNS traffic should be directed to defined DNS services. So if you detect such traffic on unknown DNS servers, you should verify it. You should analyze it. It may be something wrong. And I will talk about suspicious queries later in the presentation. Port 5053 TCP is used for zone transfer and should only be allowed between primary and secondary DNS servers. So other cases require analysis, your investigation. Outgoing UDP communication outside of DNS or NTP services should be monitored because it may be suspicious communication. And detection of short TTLs and different IP addresses for the same domain may indicate malicious C2 communications using the so-called fast flux. Frequently occurring incorrect DNS responses may indicate communication with C2. Detection of unusual TLD domains, for example, outside the geographic area of our business, or some exotic ones such as xyz.com. So it may be something to analyze. Unusual DNS traffic volumes may indicate tunneling or data exfiltration. So suspicious DNS query may include a mix of upper and lower cases, suspicious strings, for example, non-alpha numeric strings, long DNS queries, many subdomains in DNS queries, suspicious domains that are identified by a bad reputation or newly registered domains. Random names may indicate on domains generated by domain generation algorithm. So these types of queries may indicate malicious communication, DNS tunneling, or data exfiltration. And such activity we can try to detect based on NetFlow monitoring. Okay. And another examples related to suspicious DNS queries. So we can detect suspicious long names which may indicate malicious C2 communication. Here you can see example of such threat hunting search that detects domains longer than 60 characters. Another analysis may be related to analysis of rarely port domains. It may be interesting because it may be start point for threat hunting analysis. Here is a query. Sorry. Here is a query that displays domains that have been ported less than 10 times in the monitor time frame. So rarely visited domains may indicate on that the domain may be suspicious, malicious, or something like that. And the next case is related to dynamic resolution. Cybercriminals often use legitimate dynamic DNS services to host it in order to bypass organizations' firewalls and other threat detection systems. And this type of activity can be detected by searching for DNS queries from our organization to suspicious dynamic domains. Here I prepared a query detecting dynamic DNS and communication used by APT 3524, UNC 3524. But we can see that there are many such organizations offering dynamic DNS. So the functionality that makes our everyday lives easier can also be used for malicious purposes. Yeah, and many adversaries use dynamic DNS techniques, as you can see here. So it is necessary to detect this type of activity in your organizations. NGRONC is a legal reverse proxy tool that can help us to create a secure tunnel to servers behind firewalls or on the local computers that do not have a public IP address. Yeah. So NGRONC has been used by cyber criminals groups in several data exfiltration campaigns. Configuration of such a service is very simple. Just run the ngrok HTTP command and specify the directory of the data you want to share. After executing the command, we receive a URL address where this data will be visible from the internet. And in the fact, after clicking on this link, we see the shared data, and this way we can steal data from the organization. So how can we detect such a technique? We can use a regular expression to find the word ngrok in the HTTP hostname field. So we can use regex in Psycop to detect such activity. Brute force. In the credential access phase, the opponent can try to guess the password using tools such as, for example, Hydra. For example, we perform brute force attacks in the context of the SSH service, and observing the characteristics of network traffic allows you to identify such suspicious activities. And in this scenario, we see that one host stands out in terms of bytes, packets, and flows. So we can see that host which triggered this, which ran the scan was detected as generated a lot of traffic related to flows, bytes, and other attributes. Have you ever wondered how to detect cryptocurrency miners? I also once thought about it and set up such configuration, but observing quantitative data on parameters such as bytes, packets, flows did not enable me to define a pattern for such communication. But as I turned out, there are similar methods such as port numbers, 4.3s, 4.5s. Such ports should be noticed, and we can detect such activity based on monitoring ports. And here you can see the full list of ports for detecting cryptocurrency miners. Miners can also be detected at the IP address level, and Psycop CTI also provides such feeds. And here is the query which allow you to detect cryptocurrency based on CTI, Psycop CTI. Psycop has feed categories such as, for example, malware, Tor, proxy, scanner, etc. Here you can see an example of a query designed to detect communication with suspicious IP addresses or domains. But we need to remember that cyber criminals use encrypted traffic during malicious activity. Yes, and what can we do in such case? In such case, we can use JA3 fingerprints. So TLC fingerprints, JA3 client, and JA3 server, and based on this information, we can detect malicious activities, malicious or suspicious activities. Exactly. Data exfiltration through web application is very simple. So it is also worth paying attention to potential abuses related to code repositories or cloud storage. And so monitoring data transfer to certain services can detect such abuses. For example, Drive, Google.com, Box.com, Dropbox.com. You need to define in your organization what services, what website are permitted in your organizations, and Psycop allow you to detect all anomalies in this context. Okay, so now it's time for a demo. Okay, analysis based on defined dashboards. Analysis based on defined dashboards focuses on outstanding indicators such as spikes, alleged deviations, unusual combinations, etc. Based on threat detection analysis, we can analyze correlations between IP addresses, between threads. Sorry, here is correlations context of detected threats and IP addresses. Here is correlations between IP addresses. We can also analyze correlations between groups, between countries. We can also analyze statistics in context of many others views, perspectives, to see the statistics of detected anomalies, detected issues, and many dashboards in the system are clickable. So we can, for example, we can use widget filter to analyze data in context of specific traffic. We can filter out the data. We can choose technique, tactic. Most of the events of our reviews are related to tactic and technique mix, tactic and technique of MITRE attack knowledge base. So it helps you to understand what is displayed here. Yeah. So for example, we can display information in context of discovery, and based on discovery, we see such type of activity in our organization. Of course, there are much more statistics and views related to monitor, to see the some anomalies in your network. For example, black blue indicate that there is a lot of alerts related to unauthorized LDAP activity. The alerts were related to 8 unique server IP addresses, and some other statistics can help you to understand that some alerts were triggered often, and some alerts were triggered not so often. And so you can look from you can see the perspective of the detected issues. Okay, so okay, SOC and KPI. The SOC and KPI panel is useful for managers because it shows trends and statistics of detected anomalies. And security threats, of course. SICOP alerts are compatible with MITRE, as I mentioned earlier, and here you can see additional views to show issue in context of MITRE taxonomy. Yeah, and based on this information, you can prognose, you can predict future, how you can monitor statistics of all alerts related to IP addresses, alerts related to unique IP addresses, unique client IP addresses, unique server IP addresses, and unique ESNs. This is very important if you want to monitor traffic related to DDoS attacks, for example. You can monitor traffic related to specific applications if you notice that traffic related to some the number of applications is increasing in your organization. May something happened, maybe administrator added some additional systems, or maybe something suspicious. Yeah, of course, filtering by tactics and tactics and techniques is available in most of our views. A very important ability is to create our own searches. So we have created so-called threat hunting searches. So we can, for example, as you see, you can use custom searches to detect, for example, IoT traffic, external threats, internal threats, and what else, and those attacks, traffic related to database, and many other contexts of monitoring, which may be the good start point to do a threat hunting analysis. Of course, you can create own searches, and it's very easy to create own searches. But if you don't want to create searches, you can use clicking options, and based on this, you can filter data based on clicking. But if you prefer, if you like a system like Splunk, if you are a more advanced person, you can create here you can create here a query, and yeah, and how to manage the events, because when you go to alerts table, we see that we can handle the alerts. For example, we can mark event as handled, so we acknowledge that the alert were handled, and by the SOC team or NOC team or a security team. We can mark the alert as false positive, for example. If we decided that this is false positive, we can see details of the alert, to see details why the alert was triggered. We can add, we can run additional comments. For example, we can see some, we can run comment related to see to check IP addresses, for example, in other systems such as Census, Alien Vault, or something like that. We can use we can go to Mitre knowledge base as well if you want to see details about the techniques which are related to the alert. Of course, we can use some additional network tasks, and very important, we can use additional scripts, run scripts, and so there are a lot of possibilities. It depends. Of course, you can also mitigate the issue if you have integration with third-party systems. To sum up, the ability to track suspicious activity using flexible dashboards within many functions supporting data analytics makes working with the system effective, fast, and pleasant for every user, regardless of whether they are an experienced security engineers or network engineer, or a junior SOC analyst. Thanks to well thought out architecture of the SICOP system, incident handling is simple, and the possibilities of deep analysis are very large, which makes it a key system for every network and security team. So I will back to my presentation. Okay, so a few words about our company. Our team includes engineers with extensive experience in network performance and security areas, which helps in creating practical functionalities in the system. SICOP is a combination of network performance and network security monitoring. We have clients from various sectors: telecom, public, banking, so finance. We operate actively on many regions: Central and Eastern Europe, CIS, Middle East, and North Africa. We are constantly improving the system with new functionalities, and we plan to add AI to our system soon. I hope that I managed to interest you in monitoring network traffic based on NetFlow, and showed that it is a quick, easy, and cheap way to improve visibility, observability, and security in your organizations. And the scalable architecture of the SICOP monitoring system enables it to handle large volumes of data without sacrificing performance or accuracy. If the system is used effectively, you will save time, money, and get a quick return on investment. So the ROI, return of investment. Thank you very much for listening to my presentation. If you have any questions,